Hey class, Mr. Bean here. This is for Honors Physics. This will be video 15, and it's going to cover pre-lab number 40, parts A, B, C, and D. This is friction, and it's going to be the Unit 3 exam. It's going to be in four parts, as can be seen, A, B, C, and D. And the first part here, you have to come up here at your own leisure. You can do this in any order, but you'll want to come up and you'll want to do a demonstration in front of me. I need to see you make this what's called friction graph. And let's take a look at what you're going to be doing with the Pasco sensor. Okay.
Okay, I am slowly increasing the force of tension and therefore the force of static friction until the block starts to move and it switches from static to kinetic friction.
All right. So in class, virtual lab, we pulled on it until you have, this would be the maximum static friction right here. And then the block begins to move. This is the kinetic region. So you have to produce this graph with the peak here and this part here. And you want to be able to explain to me that this is the maximum static friction, which is about, in this case, about 2.25 newtons. And this is a kinetic region. If I take the mid-center line all the way over here, it's about 1.6, 1.7 newtons. So this will be part A that you'll need to that you'll need to do in front of me. I'm going to watch this. This is worth 15%. So if you skip it, the best you can get is an 85. Part B is going to be worth 30%, is worth 30%, and you're going to be determining the static coefficient of friction and the kinetic. Now, this is just like we did in the virtual lab. You'll be given three pairs of various surfaces. So in this case, surface one will be the desktop, and surface two will be wood, metal cart, and plastic cart. So let's take a quick look and just kind of see what you'll be doing here. Okay, so physics Avery, we'll say here friction. All right. Okay, friction lab. So what you're going to do for real is this will be the desktop. You're going to change to various surfaces. And what you're going to do is you want to go ahead and you'll want to make this graph here. It looks like this here. Good. Begins to move. Okay. Good. So this here is the maximum static friction, and the average value here is the kinetic friction. Okay. So you'll want to do that for a couple surfaces here. You want to do it for surface one and surface two. Um, okay. Now you may want to add some mass to it. Okay, so you have to determine what's the mass of surface two. Okay, so you have to make sure that that's going to be like the cart. So it could be, you have to measure that, and then any kind of masses that you want to add to it. Okay, so what does that mean? All right, take a look here. So it means here that this part here is going to be like the cart here. There's a cart here like this. That's the this is mass of surface two, and then any additional masses that you want to add to it. So you have the normal. So normal force will be the force normal. Okay, this will be like the mass of the cart here. So you'll need uh, the mass of the cart plus any additional masses that you add. That'll be m times g. This will be the normal force here. Okay, and then of course from your graph, you'll get this from the graph, you'll get this from the graph, and then from here you should be able to calculate the static coefficient of friction and the kinetic coefficient of friction. You should be able to get those. All right. So let's go ahead and scroll down. It'll be a score there. Part C is also in a group, okay? And on this one here, what you'll want to do is get an inclined plane. And let's double check here. So you're going to okay. Here's this flat surface here, a wood. We have a wood block here or a wood inclined plane, okay? And you're going to have some mass on top of it here, like this. Okay. All right. So, and what you're going to do is you're going to raise this up. Okay. Raise it up like so until you get some angle theta. Okay. Now, you're going to determine is the threshold angle is at what angle does this begin to slide down the plane here. Because as you move it up and up, it's not going to move because of static friction. You're going to find the angle at which it just begins to start moving. All right, so when you do that, here's what you got going on here. You have the parallel force, which is acting downward, and you'll have a force of friction up here, which is going to oppose it. Okay. All right. So what happens then is that you have the sum of the forces on the ramp here is going to equal MA, like so. Now, the ramp, okay, we're going to say going down the ramp is going to be positive. Okay. Now, it's not moving, therefore acceleration is going to be 0 initially. So when I do this here, we'll go over here and we'll go sum of the forces is equal to 0. Okay. Now, some of the forces. Force going down the ramp is, of course, the parallel force, and the force opposing it is going to be the force of friction. Okay, and that's going to equal 0. Okay, so now we have the parallel force is equal to the force of friction. Okay, so the parallel force is going to be mg, right, sine of theta here. Okay, and that's going to equal the force of friction here, which is going to be mu times the normal force. Okay, and what that is that's going to be mg. This is going to be sine of theta is going to equal, it's going to be mu mg, and it's going to be the cosine of theta, the cosine of theta. Okay, because we're on an angle here. Okay, cosine of theta. Now we look at this here, we see that the mg's are going to cancel out, leaving just sine of theta is equal to mu cosine of theta, like so. All right, and let's solve for mu. Now this is going to be mu static. It's going to be static here. This is going to be sine of theta divided by the cosine of theta. Okay, and this is my favorite trig function, is the tangent. So sine over cosine is the tangent of theta. All right, so this is a quick and dirty way to find the coefficient of static friction. I find the threshold angle. You're going to do it 3 times. Get the average value. Okay, and then you're going to okay, well, threshold angle. Yeah, this part here we can probably skip this part here, and you only want to calculate it 1 time. Okay, and then I'm going to give you a range of values. Okay, so your answer hopefully falls within the acceptable range here. Okay, so this is how you're going to do what was it, part C here. Okay, and then part D is just basically free response. It's going to be worth 40%. This has to be done individually. Okay, no copying or working with a partner. This is your answers. Okay, when I look at people here, I shouldn't see 2 answers that are similar. Okay, this is all within your skill set. All right, and this is parts A, B, C, and D. All right, answer a couple of questions here on Edpuzzle, and you should be ready to rock and roll.